Hi, this video is about a Commodore 64 emulator project I've been working on for the last few months, and now that it's matured somewhat, I thought I would put together some information on what the project is about, why I did it, and why I think you might want to consider it if you want to put a Raspberry Pi inside a Commodore 64 shell. The project is called bmc64. The BM stands for bare metal. Now you might be thinking, why another Commodore 64 emulator? Well, this emulator is a port of VICE 3.3 to the Raspberry Pi, but with one major difference from the others you might be familiar with. There is no Linux operating system required. The platform dependencies have been satisfied using a bare metal programming library called Circle. So really VICE becomes the kernel, and it's the only thing running. I think it's the better choice for projects where you want to dedicate the machine to be just a Commodore 64 and are trying to reproduce that experience of the original machine. And I'll get into how and why I think that's the case a little later in the video. I've watched a number of videos on YouTube where people put Raspberry Pis inside old Commodore 64 shells, which I think is a pretty neat project. If you're into retro machines and happen to have a shell around, or even if you want to put aside the real motherboard, it can be a fun project. I think people sometimes want to reproduce the experience they had as a kid. Some of us grew up with these machines and they were a big part of our childhood. I think we look back on the 8-bit era with a certain degree of fondness, so anything we can do to get closer to that experience, the better. There are non-destructive kits and mounts you can buy. There's a product called Keyraw from Individual Computers that lets you use a real 64 keyboard with a Pi. So it can be used in an emulator. Now this isn't a video about how to do that. Instead I'm going to point out the benefits of using bmc64 over the other options when it comes to making a dedicated 64 replica out of an old shell. The emulators that are either dedicated Commodore 64 emulators or have a Commodore 64 emulator as part of the package that I'm aware of are Combian, Pi Lizard, Chameleon Pi, and RetroPie. Chameleon Pi and RetroPie are distributions that have many different emulators, but the Commodore 64 was one of them. Now I tried these and they're all VICE, the Commodore Versatile emulator, running on top of some distribution of Linux. Now VICE is an excellent emulator, but I was disappointed overall with the end experience on the Pi. Now before I get into what the source of that disappointment was, I just want to say that these are my observations of the Linux-based Raspberry Pi Commodore 64 emulators. So I'm talking about VICE with its default settings on these particular distributions. It's quite possible that these can be tuned or modified in some way to fix some of the problems I'm about to mention. I don't know, since I didn't fiddle with the settings too much. I just used them out of the box. So the first issue I noticed was horizontal tearing. I installed all of these and at some point noticed something in common. They all produced video that just didn't feel right. Combian had some pretty bad horizontal tearing with anything scrolling horizontally in games and demos. This is a good example of what I mean. This is a slow motion capture from the beginning of Comaland 100% demo. And those vertical lines appear broken when they're supposed to be straight. I've read that earlier versions of Combian may perform better, but this was the experience out of the box with, I believe, what the latest version was. RetroPie was better in this respect. There was no tearing, but the video appeared jittery, and it looked like it was dropping frames even on a Raspberry Pi 3. Now, why does that happen? When an HDMI monitor or TV shows an image, it basically draws the image very quickly from top to bottom, left to right, pixel by pixel. When the computer's frame buffer has been rendered, it starts over again from the top, and that happens at a fixed frequency, say 50 or 60 Hertz. When you see tearing, it means the region in memory that defines the pixel information is changing partway through that refresh, and something that is in motion will appear broken because you're seeing part of the previous frame and the next frame on screen at the same time. Now other emulators like Hawk64, the C64 Mini, and possibly even other versions of VICE, maybe on Windows, they have much better video quality. They don't have this tearing problem. I believe they sync frames to the vertical refresh of the display, and that's why video looks smooth on these emulators. So the solution for this isn't new. It just didn't appear to be available on the Pi on any of the Commodore 64 emulators I tried. I read that RetroPie is supposed to have a solution to this, but it didn't appear to be working, at least for me, and if you're aware of one, please let me know in the comments below. Ghostbusters was one of my favorite games on the 64. I can notice right away if there's something off about the scrolling text at the bottom when the frames are not synced. It doesn't appear smooth like on the original machine. The text appears choppy. The second issue I noticed was boot time. Linux can take a long time to boot as it brings up the kernel, initializes drivers, services, etc. There are tricks you can do to cut that time down. Commodore is basically a Linux distribution that has been tweaked to boot straight into Vice in an attempt to give you that instant on feeling. It boots in about 13 seconds. Other distributions, especially the ones that are multi-emulator, can take a minute or even more. Now, if you're looking to reproduce the Commodore 64 experience where the sole function of the console is to act like a Commodore 64, this really takes away from that. The original machine booted nearly instantly. Again, if you look at a game like Ghostbusters, the bouncing ball is a good indicator of audio synchronization problems. The ball should reach its apex on the beat of the music. I noticed on Commodore the audio delay was significant enough to notice it was off from the original machine. This can be improved by adjusting the audio buffer size, but you'll notice if you try to drive it down too far, you may start to hear popping sounds. I even saw complaints about the machine being too slow on an Raspberry Pi 2 when I tried to bring the audio buffer down. I think the Raspberry Pi 3 did much better at this. As a side note, in the 8-Bit Guy's review of the 64 Mini, he measured the audio latency using a delay test program he wrote. The latency measured a whopping 360 milliseconds, which is pretty long. Now, I don't have a 64 Mini myself, so I can't measure, so I'm using other people's results, but from what I've read, the latency hasn't improved much, if at all. If you know otherwise, please let me know in the comments. Then there's video latency. When you press your joystick button, you want your character to jump or your ship to fire right away, or at least as quickly as it did on the original machine. But emulators generally can't do as good a job on this. There's always going to be some delay. In the same video, the 8-Bit Guy measured the 64 Mini's video latency to be around 130 milliseconds, which is 6 to 7 frames. And that, in my opinion, is starting to get into the annoying zone. I think I start to notice latency around 100 milliseconds. A note on this, I don't think Vice on the Raspberry Pi, even on Linux, is as bad as the 64 Mini. I think the 64 Mini has a fairly low-powered SoC, which may be partially responsible for that measurement, or perhaps it's just that they didn't tune it properly. I'm not sure. Finally, the last issue is probably not one often run into by most users, but it can be just as annoying as slow boot, and that is a shutdown sequence being required. With Linux distributions, you're technically supposed to start a shutdown sequence before cutting the power to avoid SD card corruption. That's why people recommend putting in a power block device when you put the Raspberry Pi into a Commodore shell. That device has a button that signals to Linux to perform a shutdown rather than cutting power abruptly. Now, in practice, I think a lot of people just yank the power, but keep in mind that Linux could be writing to the card even if you aren't using the device at the time. There are all sorts of processes in the background that could be doing things you're not aware of. You can watch the green activity light on your Pi while running one of these emulators, and even if you're not doing anything, it may flash occasionally, and that could be the result of logging or other housekeeping tasks. So what's the problem here? Why do we have these issues? Here's a diagram of what you're getting with these Linux distributions. You've got many layers of abstraction, inter-process communication, buffers being copied and passed around, services running, etc. General purpose operating systems are great, but if you're looking to make a machine do one thing, that stuff just basically gets in the way. So with that in mind, I asked myself the question, can we do better? And yes, we have bmc64 is the result of this, and let's take a look at its feature. It's a 64 emulator specifically for the Raspberry Pi 2 or 3. It boots in 4.1 seconds, no horizontal tearing, smooth scrolling, no drop frames or jitters. Audio latency is down to about 80 to 90 milliseconds, which is 4 to 5 progressive PAL frames. Video latency down to 35 to 45 milliseconds using real Commodore joysticks, using the GPIO, and you can turn it off just like the real thing. So the boot time alone will make your project feel more like the genuine thing. I had a version that got that boot time down to 3.5 seconds, but a last minute change added an additional half a second, so I'm going to try and get that half a second back at some point. Again, you get smooth horizontal scrolling, so your demos will look great. Audio latency, much better than the 64 Mini, and better than Commodore. and again, turning it off just makes it feel, without worrying about shutdown, makes it feel more like the original machine. So again, if you're thinking of putting a Raspberry Pi inside a Commodore 64 shell, I think this is really what you want. At least this is what I wanted. bmc64 is still Vice. However, like I said earlier, the platform dependencies like video, sound, and input are implemented direct to hardware through the Circle bare metal library. I think I'll save the technical stuff for another deep dive video, but the idea here is to eliminate all the bloat introduced by an operating system. And just to note that bmc64 isn't the first bare metal C64 emulator for the Pi, but as far as I know, it's the most complete and possibly the first time Vice has been ported to a bare metal environment. I ended up doing a lot of work inside the standard I/O library GlueCode to give Vice what it needs. So feature review, quick boot time. We can watch bmc64 boot here. It's 4.1 seconds. That's from the moment you apply power to the time you see the blue screen. And I noted that sometimes my HDMI monitor actually takes longer to recognize the video signal is there than it does for the emulator to get to the ready screen. That's why I'm using a composite monitor here. I'm even considering hacking my key rod to use the switch on the right to cut power instead of being a mode switch. So if you don't have one, it might be helpful to know that the switch on the right is not actually a power switch, it's a mode switch that changes how the keyboard is mapped. I think it might be worth it to solder the mode connection to be permanently set for a 64 and then use the switch for power instead. We also get smooth 50 or 60 hertz horizontal scrolling with no tearing. That's because every frame is held on screen for precisely 1/50th or 1/60th of a second, depending on what your machine timing is set to, and that's thanks to the vertical sync wait function provided by the Raspberry Pi's video core. And this makes it feel much more like the original machine. Again, that's not something new. The 64 Mini does it, and I think other emulators do as well. Audio latency, here's a capture from my oscilloscope. Audio latency is currently measuring to be about 80 to 90 milliseconds, which is better than the measurements I made on Linux or what was reported for the 64 Mini. I think the best I got was 130 milliseconds on Combian. bmc64 is only 4 to 5 PAL frames behind. bmc64 also uses the resid engine by default. I read some complaints about resid causing Combian to be slow. Again, this is a must for a 64 emulator. You can hear a huge difference if you listen to the last sequence of Comaland 100%. The digitized voices are static using the fast SID engine, but they sound proper using resid. Video latency, another advantage of bmc64 I didn't mention earlier is that you can hook up real Commodore 64 joysticks directly to the Pi using GPIO pins. I have instructions on the project website on how to do this. Measurements between GPIO joystick signals going low and the emulator composite display change have been measured to be around 35 to 45 milliseconds, or basically 2 to 3 progressive PAL frames. Again, better than the 64 Mini and slightly better than Combian by 1 frame maybe. I think if you use USB joysticks, it's basically a tie. It's also worth noting that the HDMI monitor that you're using will probably account for at least 1 frame delay. Even if you have your monitor set to game mode, it's likely the case. I'm not aware of any HDMI monitors that are 0 latency, so even with the Ultimate 64, measurements have been done that show that even though the machine itself has basically 0 latency with regards to its output, you stick an HDMI monitor on the other end of that signal and it's doing some of its own processing, which further delays the signal. And finally, with bmc64, you can safely cut the power to your Raspberry Pi without worrying about SD card corruption, and that's because 1, there are no background processes that could be using the SD card without your knowledge, like logging tasks, for example. And 2, there's no dirty write sector cache in effect at any given time, and by that I mean there's never a situation where the application layer thinks it has written data to the disk, but it has not actually been flushed. There's never a situation where data has been partially written, unless a file is actually being saved at that very moment, but that is very quick. So this eliminates the need for a power block, at least for a dedicated 64 emulator anyway. Finally, could this have been done on Linux? Did I have to port to another platform? I think the answer to that is probably yes, but that wouldn't have been nearly as interesting. Perhaps a kernel module could have solved some of these issues in a different way, or maybe some settings could have been tweaked. Maybe some process priority changes or other tricks. Some of the issues I mentioned before could probably have been solved differently. I think boot time would probably be the most challenging part. What are some of the disadvantages with this solution? Not all Vice features are available. Vice has many, many features, and the UI does not cover them all. Although I am adding as many as I can, or as many as are being requested. And timing is not exactly that of the original machine. The original machines ran at 50.125 Hertz for PAL and 59.826 Hertz for NTSC. But because we're syncing to the vertical refresh of the HDMI signal, that's down to exactly 50 or 60 Hertz. So you're going to be a little bit off, but I think it's a small price to pay given the advantages. And we have to remember that this is, at the end of the day, an emulator. It's not perfect. There are many cases where an emulator won't perform like the original machine. And also, if you're looking to use your Pi for multiple machines, like a Nintendo, Atari, and you want them all in one image, this is probably not the solution for you. Although bmc64 can be used alongside other emulators, you would need a bootloader to select which kernel you would want to boot. And I said earlier that I thought bmc64 was the better choice for putting something inside the Commodore 64 shell, but that obviously is only true if you're sticking to an emulator. If you want something even better, then you would get something like the Ultimate 64. The Ultimate 64 is not an emulator, it's actually another implementation of a 64 using different hardware, so you get even better performance out of that. So that's the end of my video. I hope you found it interesting. Again, my goal was to provide an alternative for people who want to put a Raspberry Pi inside a C64 shell for that authentic experience, and I'm pretty happy with the results and learned a lot from the project. Depending on interest and time, I think I may do a second video where I get into more of the technical side of how this came together and some of the interesting problems I came across. Thanks for watching.